This is Chapter 5, Lesson 6, Use the Pythagorean Theorem. So, we can use the Pythagorean Theorem to solve right triangles, of course. So, the Pythagorean Theorem can be used to solve a variety of problems. It is helpful to use a diagram to determine what part of the right triangle is unknown. The Pythagorean Theorem in 3 dimensions. You can use the Pythagorean Theorem to find the missing measures in 3-dimensional figures. So let's take a look at some examples. Example 1 says write an equation that can be used to find the length of the ladder. Then solve. Round to the nearest tenth. So here's my building, right? So there's 18 feet between the bottom of the building and the top of the ladder. And there's 8.75 feet from the bottom of the building to the bottom of the ladder. And I want to find how tall the ladder actually is. So this forms a right triangle. So notice that the distance from the building itself, and the ladder form a right triangle. So I can use the Pythagorean Theorem. A squared plus b squared equals c squared. Well, I have both of my legs and I'm missing the hypotenuse. So 8.75 squared plus 18 squared equals c squared. 8.75 squared is 76.5625. 18 squared is 324. When I add them together, I get 400.5625. And I take the square root. Technically, I need to take the positive and the minus square root. Okay, so I get 20.0. Since length cannot be negative, the ladder is about 20 feet long. Okay. Number 2 says write an equation that can be used to find the height of the plane. Then solve, round to the nearest tenth. So, the distance between the planes is the hypotenuse of a right triangle. So here's a plane and here's a plane. This one's on the ground. This one's in the air and it's flying. Okay, because you can notice I can take a straight line from the plane down to the ground. That's b miles. And from the ground to the other plane, it's 10 miles. And I know my hypotenuse, the distance between my two planes, is 12 miles. So this forms a right triangle. From here, I can see that I'm missing a leg. So a squared plus b squared equals c squared. 10 squared is one of my legs, plus b squared, that's the other leg that I don't know, equals 12 squared. So 100 plus b squared equals 144. By the subtraction property of equality, I can subtract 100 from both sides. So I get b squared equals 44. And then I take the square root of both sides. So b is approximately plus or minus 6.6. And since length cannot be negative, the height of the plane is about 6.6 miles. Okay. Example number 3 says a 12-foot flagpole is placed in the center of the square area. To stabilize the pole, a wire will stretch from the top of the pole to each corner of the square. The flagpole is 7 feet from each corner of the square. What is the length of each wire? Round to the nearest tenth. So here's my flagpole. My flagpole is 12 feet high, right? The distance from the flagpole to the corner of the square is 7 feet. This forms a right triangle. I'm missing the length of my wire, so that's my hypotenuse. So the length of one of my legs is 7 feet. So 7 squared plus the length of my flagpole, which is my other leg, is 12 squared, equals the length of my wire squared. So I have 7 squared plus 12 squared equals BC, which is how they've labeled my diagram. Okay? 7 squared is 49, 12 squared is 144, and that still equals the length of my wire. 49 plus 144 is 193. And I take the square root of that, which gives me approximately 13.9. Since length cannot be negative, the length of the wire is about 13.9 feet. Okay. So on the next page, there are 2 try-it problems. I want you to go ahead, pause the video, try them out, and when you're done, we will go over the answers together. All right, now that you've had a chance to try out the try-it problems, let's go over the answers together. Letter A says, Mr. Parsons wants to build a new banister for the staircase shown. If the rise of the stairs of a building is 5 feet and the run is 12 feet, what will be the length of the banister? So over here in my diagram, I have my set of stairs. So the rise, how tall they are, is 5 feet. The run, how long they are, is 12 feet. Notice that this forms a right triangle. So I can use the Pythagorean theorem. A squared plus B squared equals C squared. So I have 5 squared plus 12 squared equals C squared. 5 squared is 25. 12 squared is 144. 25 plus 144 is 169. I take the square root of both sides. So 13 equals C. So 13 is the length, and it's 13 feet, is the length of my banister. Letter B says the top part of a circus tent is in the shape of a cone. The tent has a radius of 50 feet. The distance from the top of the tent to the edge is 61 feet. How tall is the top part of the tent? Round to the nearest whole number. So I can see that this forms a right triangle. One of my legs is 50 feet and my hypotenuse is 61 feet. So because it's a right triangle, I can use the Pythagorean theorem. Okay. One of my legs is 50 feet. So 50 squared. I don't know what my other leg is. And my hypotenuse is 61. So 50 squared is 2,500. And 61 squared is 3,721. By the subtraction property of equality, I can subtract 2,500 from both sides. So I get B squared equals 1,221. Then I square root both sides. So I get 34.94. It keeps going. And I'm rounding to the nearest whole number. So B is approximately 35 feet. So this tells me that the tent, the top of the tent, is 35 feet tall. And that is the end of lesson 6.